first of all, the typical stuff, please silence your cell phones.
Check.
By the way. Okay, you are probably, as you are here, familiar with everything that PaaS has to offer, so I will not go into too many details. Apart from that, all the slides are available afterwards. So first of all, I'm very happy to have this session together with my good friend Tom Martens, who is a BI consultant, lead expert, architect, and actually to be book author, and is working for Betelligent. He has more than 20 years experience with creating analytical solutions with Microsoft Data Platform technology and is a Data Platform MVP.
Thank you. So I'm happy to be here on stage with Gabi, also a close friend of mine. And she is doing amazing things with everything, analysis services, Azure SQL warehouse, and data in general.
So after the session, please remember to fill in the session evaluations. We are not here for the first time, so obviously we weren't too bad the last times because we were chosen again. But, well, we are always happy to improve. So if you have something which we could do better, please let us know. If you are satisfied, please also let us know. We're happy to hear that. But, well, we want to improve, so that's really helping us.
So, as the title of the session maybe suggests, it's about aggregations. Why aggregations, how to design aggregations, and something about architecture. So why aggregations? Maybe all of you know this already. Thanks. And it's about performance. So this is the main reason of designing aggregation, using aggregations with Power BI. It's about performance, and this also starting to count if the amount of data is growing continuously. So it's just about performance.
Okay. Let's get started with designing aggregations. Like Tom already asked, there is a lot of videos already available presenting the principle of aggregations. And you can also easily see some of the things we will just quickly recap to get us all on the same page. First of all, if we really go into a longer recap, aggregations is a familiar concept. Who of you worked with Analysis Services Multidimensional? Thank you. I love multidimensional. So, no, and aggregations was already part of Analysis Services Multidimensional. It was a powerful feature, but it had some kinds of limitations and downsides. So first of all, whatever you did there, those aggregations you actually designed there and applied there was something that was strictly limited to the use in analysis services. It was a special feature of analysis services, and what you did there was also only meant for analysis services. So what you actually did is you created certain aggregations that were, so certain definitions how data should be aggregated, on which level of granularity of a set of dimensions that you designed, and the results would be just processed like the whole cube was, so as additional files inside your file storage, inside your cube space. Whenever you applied or whenever you implemented changes to the dimensions that were part of the aggregations definitions, of course you always had to take care that you adjusted your aggregation design if necessary. So it was a lot of actual work. Aggregations was a MOLAP thing, so of course you have things like proactive caching, for example, that also can improve performance in Analysis Services Multidimensional if you use rollup, but aggregations was a MOLAP-only feature. You couldn't do anything like rollup aggregations easily. And, well, you had some support in designing aggregations. You had your usage-based optimization wizard that allowed you to actually track the usage information, the queries that were run on your system, and a wizard that actually proposed certain aggregations or designs to you to simplify this. But on the long run, you still had to design that on your own, or you actually even designed the aggregations completely manual. And this was, well, it wasn't really user-friendly, to be honest. The results were quite good, but the way to get there was not that easy. So, as I mentioned, there are videos around, but just to get everyone on the same page what we're talking about, let me quickly show you how in Tabular we now would actually apply aggregations or aggregation designs to an existing model. I prepared a model where I already applied everything, but I would just like to show you what I actually did, what the different features actually mean, and how you can easily detect if your aggregation design is actually applying to your model. So, first of all, you all know Power BI Desktop, your development tool for Power BI, where you can actually design your model and also, of course, apply your aggregations. So what I did here, I'll just make it a little bit larger. We have a very, very simple and easy model. This is also based on the New York taxi trip data that is used in Christian Wade's enterprise scale model. We're not talking petabytes of data here. This is just a very, very small set, but we're just talking the principle. In the background, there is running an Azure SQL DW. So this is something which we will talk about in the architecture part of this session, why certain technologies in the background could be more advantageous than others. And what you already can see here is that I have, apart from several dimensions, so unfortunately I have to admit, this is not really best practice from the naming perspective, so I probably should change this for the next time. So naming the dimension table would be very helpful, but you see from the star schema that I have several dimension tables and actually two fact tables. I have my trip table and I have a fact table that is called fact trip ag, and that is actually what aggregations in Power BI are all about. You don't have the necessity to run any kind of designs, wizards, whatever, where you have to pre-decide which dimension level granularities you actually want to apply to, and then something is processed. You just design a table with a similar structure that your aggregation or your basic detail fact table has. Of course, this is an aggregated version of your fact table. So of course you have to decide which level of granularity you actually want to apply. But the design is pretty easy. It's just another table. It's related to some, but not to all of the dimensions. So if we're looking at this, for example, the aggregation table is connected to my geography dimension. It is connected to my date dimension. But it's not connected, for example, or related to my weather dimension, to my license, my medallion, or whatever. So it's just aggregated to a subset of the dimensional data that I'm looking at here. The next thing that you need to do after you actually designed this aggregated table and loaded it into the system is you need to actually explain to the system how you want those aggregations to be applied. And this you do by actually choosing the Manage Aggregations menu item from the context menu, or you also have it available in the detailed menu on the right side, where you can define per aggregation table, and I'm saying this explicitly because you are allowed to include several different aggregation tables in your data model if you want to, if this makes sense to your model. You are allowed to define per aggregation table, first of all, the name of your aggregation table, which makes sense, the precedence, which is especially important when you are using several aggregation tables, because by the precedence, you are actually creating something like a solve order you had in multidimensional before. So you are saying which of those aggregations should actually be applied first. So you can say something like, I have an aggregation based on day, I have an aggregation based on month, and an aggregation table based on year, for example. That is possible. And you could say, look if the year fits first. If it doesn't, look for the month. And if that even doesn't fit, then look for the day. So you can choose the precedence to actually decide, or to make the system decide what to apply in which order. And then you go column by column through your aggregation table, and you actually say per column how this column actually should apply to a certain, in regards to a certain detail table. So if we're taking the fair amount, for example, the fair amount is the aggregated sum of the column fair amount in your detail table trip. Pretty obvious. So when you're running a sum somewhere in your queries, either Excel, Power BI, whatever, the storage engine actually detects that it can apply this kind of aggregation, and it can look up the value in the aggregation table instead of the detail table. Of course, only when you are hitting the level of detail, the aggregation level, if only the dimensions that are related to this aggregation table are also part of the query, or at least no other dimensions are part of the query. And if we're just quickly looking at the different opportunities you have here to choose, you see that you have a count, which makes sense. You have a min, max, and sum, which is very obvious. And let me scroll down a little bit. You have a count rows. A count rows or count table rows is a very specific kind of aggregation where you actually just say how many rows are available in this detail table. This is especially important when you are considering the calculation of an average. If you got aware, there is no aggregation average available in the assignment or in the values you can choose for the aggregation type, which makes sense because average is something which needs to be calculated on the fly. You cannot pre-calculate it properly. So the engine is clever enough to actually say, I have a sum and I have a count rows, and with those two combinations, I can calculate the average based on the aggregations on the fly. So if you have a sum and a count rows, then you can get the average as well. When you're thinking about what might be missing in this situation, you don't have a count distinct. Yeah, sorry? Yes. Okay, let me rephrase the question. If your calculation would be divide the sum of fair amount, for example, by the sum of, I don't know, passengers or something like that. If you have in your aggregation table some aggregations for both of those measures, the engine will be detecting this and will also get the values from the aggregation table. So this is possible. The engine is always trying to identify if it can resolve the formula in a way to achieve all values necessary from the aggregation table. And if that's possible, it will apply the aggregation. If any of the elements needed are not coming from the aggregation table or not from this aggregation table, of course, no match will be available. Okay? Makes sense? Okay, so what is missing here in the selection is a count distinct. You can apply a count distinct, but the count distinct is actually applied by a group by. So for example, in your fact table, if you want to apply a count distinct of a customer, you can just mark the customer ID column as a group by, and then actually the system is calculating the count distinct based on this. But the group by actually has another functionality which, in my opinion, is quite important talking about aggregations. So I was talking about the possibility to say, I want to have an aggregation table that shows me my aggregation on day level, on month level, or on year level. And this is something which normally doesn't happen easily or doesn't fit easily in tabular, because you need to actually assign or relate the fact table, even the aggregation table, to your date dimension table, to have this applicable, to have this really handy. And, well, my date dimension table is on day level. So how can I actually relate my aggregated fact table to my date dimension on another than the key level? And this is also possible by group by. So in that situation, I wouldn't actually create a relationship between the aggregation table and my date dimension table, but I could have something like a month number or a month name as a column inside my aggregation table. And then I would say this is a group by of the respective column, month number or month name inside my date dimension. And that would lead for the engine to actually detect that this is a relationship that can be applied in this situation if I select the respective level or the respective column from my period dimension. And by this, you can actually even aggregate up your fact table, your aggregations on a non-key level of a certain dimension. And this is definitely something which adds a lot of functionality to aggregating up to aggregations in Power BI. Okay, so this is more or less what you can do here, or what you need when you want to apply your aggregations or actually include your aggregations into your Power BI desktop model. And if you want to actually check if what I said is correct and if the aggregations are actually detected by the system, the recommendation or the recommended tool to do this is DAX Studio. DAX Studio, who of you is not aware of DAX Studio?
Awesome.
Okay.
Oh, I saw two hands.
There are two tools actually that need to be mentioned when we are talking about freeware tools available that definitely give you a lot of additional support when you want to create something or implement something for Power BI or tabular models at all. One of them is DAX Studio, coming from SQL BI, our two Italian friends, Alberto Ferrari and Marco Russo, who are also here. And this tool allows you to easily create DAX statements. It has syntax highlighting. It allows you to format everything. And the most important thing for our purpose at the moment is it supports actually the performance analysis of your queries. Like, for example, you are used from T-SQL queries from Management Studio. So you can look at the query plan, you can look at the server timings, you can apply things like clearing the cache to get a most specific or most precise result of your actual performance analysis. And you have a lot of additional options here, just to mention a subset of this. And this is important. Tabular Editor, on the other hand, is, like it says, a tool that allows you to actually create tabular models based on JSON, like the BISM Normalizer tool from Christian Wade. And this one is really up to date, really focused, because you can already use it to create calculation groups, for example. You even could create calculation groups in Tabular Editor before it was available in SSDT, for example. So if you look for additional tools that help you in your work with tabular models or with Power BI, please look for those two tools. Okay, first of all, let's quickly look at our data model. So just a short recap, which dimensions are actually related to our aggregation fact table. So we have the geography dimension and we have the date dimension. whether Hackney license, medallion, and time, for example, are not related. So when I run the first query, which is actually just saying sum everything up, give me the sum of passengers or the count of the sum of my passenger count column from my trip table, and I'm just referencing here my detail fact table. I don't need to actually decide on query level if I expect it to come from the detail or the fact table. I'm just referencing my detail fact table here, and I'm just saying give me the sum on my month level. And if I run this query, let me clear the cache just to make sure. If I run the query, it's pretty fast. If I look at the result, I see that I get my month, year, and my sum of passenger count, so it looks like that is actually what I expected. And if I'm now looking at the server timings, I see that I get an information which is called rewrite attempted. And that is actually what is done by the engine in the background when I'm trying to hit an aggregation. So it's trying to rewrite the query in a way that allows me to gather the data from the aggregation table instead of the detail fact table. And as you can see, the result is match found. And if I'm looking very much to the right at the rewrite attempt and at the details, I can see that this match is actually mapping to this aggregation view that I'm using here. And now I have to quickly zoom out again. If I'm looking at the query itself, here you can actually see that it's getting the data, it's getting the values out of this aggregation table instead of the actual detail table.
This means mission completed.
Yes. Just to show you that it's not working when we expect it not to work, I'll just do a quick query based on the hour number. So I want to see my passenger count per hour of the day. And if we remember correctly, the time dimension is actually not related to my aggregation table. So if I'm looking back at the results, I see rewrite attempted, but attempt failed. So in this case, I'm using a dimension that is not related to the aggregation table. And in this case, this leads to, and it's interesting to see here, because I want to quickly point another thing out, that now I'm getting a select statement. So I'm getting a T-SQL statement that is getting all of this data out of my trip table. And that is because my detail table is actually a direct query table. So the data is actually residing inside my Azure SQL DW. It's not processed into the tabular model, while the values of my aggregation table are actually imported, processed into my tabular model, into my Power BI data set. So this is just another the last point I want to show you here. This is related to the feature called Composite Model. Who of you is not aware of composite models? Okay. Composite Model is one of the most important features in my point of view that came up recently. I think it's available since August last year, something like that. Yes. And which was actually required to enable this functionality of aggregations. So when you were talking about storage modes in Power BI before the Composite Model, you had import, which means the data is actually processed into the engine or into the cache. And import allowed you to actually combine different data sources, to combine tables from different data sources. Or you had the two versions of direct query. The one is live connection, which means a direct query to an analytical systems like Analysis Services Tabular or Multidimensional. We will leave this out for the moment, but you had the classical direct query going down for a SQL server, for example, which means you are creating the model in Power BI. All the meta information, the relationships, the calculated measures are residing in Power BI, but only the meta definition. The data itself is still residing in the actual data source. And when you're writing a DAX query against Power BI in direct query, it's translating this query into the query language of the actual data source. So with SQL Server, just a moment, with SQL Server, it would be T-SQL, and it's sending this query down to the original data source, is gathering the results up, performing any kind of aggregation or whatever that still is necessary, and then is presenting the result. Question?
Is that what it's called query folding?
Yeah.
From TSQL to DAX?
Yes.
Exactly.
Yes. That's, so the question was if that is what is called query folding, so the actual rewriting of the query in a different language. Yes. So direct query had one important limitation. Direct query in the beginning allowed you to actually only connect one single data source. You could, of course, choose different tables from this data source, but as soon as you decided for a direct query data source, you were not allowed to add any kind of additional data sources or combine it with any kind of import data sources or import tables. And Composite Models actually gives you exactly this functionality. Composite Model allows you to combine different direct query data sources or even direct query and import data sources. Even more, a composite model allows you to decide per table inside your data model if you want to have this table in direct query or in import mode. And there is a third mode, which I just want to mention quickly, which is called dual. And this mode is actually applicable for any kind of dimension tables that are combined, like in this case, with a direct query detail fact table, and on the one hand, and the import aggregation table on the other hand. And this actually says when this dimension table is used in a query that is hitting the aggregation rewrite attempt, so if the data is actually gathered from the import aggregation table, this dimension table is behaving like an import table. And if the rewrite attempt fails, so the data is actually gathered out of the direct query data source, then this detail table is also treated like a direct query table, so the data for this dimension table is also gathered from the direct query data source. And this is a very, very powerful and strong feature that was absolutely necessary for aggregations, but which apart from that also allows you to just write much more, let's say, interesting and complex models than you could before, because especially this combination of direct query and import is something that was really required before. Any questions so far? Yes, please?
I think I'm a little confused. You talked about a tabular model, and then you created this aggregation within Power BI.
Yes.
Is that on a tabular model?
Okay, so question is, I was talking about a Power BI data set and creating these aggregations inside the Power BI data set, but I was also talking about a tabular model. So what is the relationship, more or less? A Power BI data set is actually a tabular model in the background. So when you're opening up Power BI Desktop and creating a model, Power BI Desktop is spinning up a tabular Analysis Services tabular instance on your PC, on your notebook, whatever. And this Power BI dataset is actually a tabular model inside this instance. So this kind of logic is actually applying to Power BI datasets or tabular models in the same way. Apart from, and that's important to know, this feature of composite models is only available for the tabular models in Power BI. The tabular model or the tabular services stand alone does not offer the feature of composite models. So
Currently
it's basic.
not. Currently not. It's
well,
maybe sooner or later, maybe.
Up to now, actually it was said that it will not support composite models. We still hope for a change, but we don't know anything else yet. So, but apart from that, it's more or less the same kind of technology, but there are slight differences in certain kinds of functionalities that are allowed. But in the background, it's actually more or less the same. Any other questions? Okay. So, back to the slides. That was just a quick demo of what is possible with aggregations. Of course, you can extend this to a much higher level to build much more complicated aggregations, several aggregation tables, and so on. But just as a quick recap, actually, assigning those aggregations in Power BI or actually implementing those aggregations in Power BI is not really complicated. It's just configuration on a table. That's really easy. In comparison to what you had to do in Analysis Services Multidimensional, this is really nice. This is really easy and user-friendly. You just have to understand some principles, and tools like DAX Studio make it really easy and really quick to check and to actually find out if your aggregation implementation does fit your requirements. So, what is the difference between, so I said in the recap, we had some limitations and some things with analysis services. What is the status nowadays? The big advantage of aggregations, or the big advantages of aggregations in Power BI are, you are designing or you are using this kind of aggregation table. To be honest, this aggregation table is something you normally, or you actually define inside your data source. So this is a part of your original data source, which means you can put it in several different technologies. So you can actually create your aggregation table inside your SQL server, or you can run an ETL process and render it as a CSV file that you put on a data lake or whatever. You have the choice of technology that you want to use to actually create this aggregation table. Also, the result of this aggregation table, the table or CSV file or whatever you actually are using, is available to other technologies as well. It's not a development, not an implementation that is strictly limited to Power BI. It's a general approach what you can use. You can use it to the most advantage in Power BI maybe, but the result is still available openly, and you can use it in different applications, in other applications as well. And as I mentioned, you have the choice if you want to have your aggregation table applied inside your model in direct query, which means you have almost the most recent access to your data. You have just-in-time data. Or you can import it. You can process the data into your data model, which will allow you for the most speed, the most performance improvement. But, there always is a but, you still have to design this kind of aggregation table. Well, integrating it into the solution is easy, but, well, it's not like there is something like a wizard where you can say, this is my detail table, render me an aggregation table. You have to actually plan for this. You have to think about which level of detail do I need, which technology do I use, and I'm sorry, and that means you actually have to do a lot of work on your own. You have to do all this thinking, this planning, this designing before. It's not, well, it looks so easy when you're looking in Power BI desktop and you're just configuring something, but there is a lot of implementation you have to do before. Question?
So the aggregation table, that will be a predefined view on the SQL server?
This is actually the architecture part. And this is, until now, we have seen the fun part.
Question.
And now,
yeah.
It depends.
Let me repeat the question. The question was if the aggregation table is, for example, a predefined view in the SQL server. In this case, this is exactly the case. So this was a view on the SQL server. But like you said, we will come to this during the session. Okay.
Do we know if there will be, or are there any plans to have sort of, I have the import table defined in Power BI and defined aggregation in desktop?
Okay, question is if there are any plans to, let's say, support something or create something like a kind of wizard or process that allows you to say, this is my detail table. Here in Power BI desktop, I have a wizard that creates me an aggregation table based on this detail table. Not as far as we know.
No.
We don't know about any plans like this. But while you were asking this question, and while we were also talking about the possibility to choose between direct query and import, apart from all the design work you have to do, the implementation you have to do upfront, you also have to take care of keeping the detail table and the aggregation table in sync. So when you're thinking about having a direct query detail table and an import aggregation table, what happens with all the fact data that is available in your direct query data source since the last time you processed your aggregation table? This is something which is your responsibility. You have to take care about that. And that is why we actually decided to have this session, and which we want to talk about a little bit more in the next few minutes.
So what Gabi already mentioned is, until now we have seen the fun part, and now comes the thinking part, or the more interesting part, is we have to identify what we want to have been aggregated. Maybe it's the most read data, or the data that is most used in our reports, our report pages. And then we have also to consider what we want to have be aggregated. Is it also possible to aggregate this data? Meaning, if we have some kind of DAX measures that we want to calculate, is it possible to aggregate the data or not? Because if we aggregate data, we are also omitting detail, and then we cannot calculate our measures any longer. So we have to decide or choose the proper application of where we want to store, calculate our measures. Then we have to apply the relationships. And what Gabi was also already demonstrating was the storage mode of our tables, and the aggregations have to be tested, because just because we want it to be aggregated or use the aggregation table doesn't necessarily mean that our measures are actually hitting these aggregation tables. So it means we have to use DAX Studio, currently the only tool that provides insight about this. Until now, we just collected data, group data, meaning we aggregated data into a certain kind of aggregation table, and we have a detailed table. And now, quite often it's a concern who's allowed to see what kind of data, meaning who of you is familiar with row-level security?
Or the other way around, who is not familiar with row-level security?
Okay,
everybody.
So everyone has some kind of data access issue, meaning there are concerns that not everyone should see all the data. And this also implies and imposes some kind of consideration. If you're using different technologies, meaning, for example, the SQL Server as the store for our data detail tables, is supporting some kind of single sign-on. So this means if this user connects to Power BI, to the service, and sees the aggregated data, and now he wants to drill down because he looks into another report page, the detail table, this data source has to support some kind of single sign-on. So this is very important. If we have this kind of security issue with row-level security, for example.
Or as an alternative, if you are actually applying the row-level security not in your data source, but in your Power BI data set, which is also an option by applying roles, for example, then you have to keep in mind during the design time of your aggregation table that you can that the lowest level or the highest level that you can actually aggregate up to is the level that you need to apply for your row-level security. Because there is no way, let's say, for example, you have a regional structure and you want to have an aggregation table that is actually aggregating up to region level, but your row-level security is applying on country level. Well, I think the engine is actually capable of identifying that in this kind of situations, aggregations are not actually applicable and will not use the aggregations instead. But this will probably not help you really speeding up the performance of your report. So maybe it could be a better choice to actually just create the aggregation table on country level, which is the level of your row-level security, which is not the best improvement, but still it would allow the engine to actually use the aggregation table instead of just misleading it because it's not applicable with row-level security. So this is definitely something which you need to keep in mind.
So, and another, maybe this is my favorite topic of talking about aggregations, is if there is a detailed table stored, where data is stored, for example, in SQL Server, and I load the aggregation table into my Power BI dataset, leveraging the Composite Model, combining direct queries, direct query data sources, and import mode data sources. There's always a gap between data has arrived in my detailed table and the data is processed, meaning imported into my Power BI import table. So maybe this is an emotional problem because we have to also answer the questions. Is it necessary that detailed table and aggregated table are always in sync? Or is it, are our users mature enough to are able to cope with gaps in the difference between aggregated table, because the detailed table has newer detailed data that has not been processed already, and now I'm drilling down from my 100 and now I'm see 110. So this has to be considered. And actually, if you are considering Power BI Pro, I can 8 times a day refresh my Power BI imported data. If I'm in a lucky situation where I'm having Power BI Premium available, I can process my data 48 times a day.
On a scheduled refresh.
On scheduled refresh. And this gap between data has arrived in the detail table and will be available in the aggregation table has to be, maybe the luckiest situation is if you say, or your users say, we don't care. It doesn't matter if it's aggregated shows 100 and detail, if I'm drilling down, shows on 110. Maybe you're in a lucky situation, yes?
Question, could you use some kind of DAX formula where if it's in the past weeks, you would use the aggregated table, and if it's in the current week, you would use a direct query?
So
the question is there some kind of, so would we apply something like calculating a measure that says if I'm in the past, use the aggregation table, if I'm current, then use the detail table? That was the question.
Yes, this can be, this is not, basically this is not the typical use case, but can be, let's say, architected, because what is in the aggregation table, what's in the detail table, but this has to be taken care of in the modeling of the dimension tables.
So maybe one thing to add here. There is one thing I have to actually mention. When you think about the model that we looked at in the demo, you saw that both tables were actually visible. This is coming from older times when aggregations were quite new, and I actually kept this model because I like the view of this. When you're now marking an aggregation table, when you're creating a new Power BI dataset and adding an aggregation table and marking it as an aggregation table by configuring it, then it will be automatically hidden. It's not really meant to be directly addressed. That's not the case. But like Tom said, the actual purpose is to be identified by the engine. So the design of your reports, the choice of the dimensional attributes that you're using in your report, or even the design of your dimension is what you actually should apply to decide if the aggregation table should be hid or not. Right.
So as I already mentioned, or Gabi already mentioned, if you are on Power BI Premium and then can use scheduled refresh, means we can 48 times a day, or yes, a day, we can refresh our data. This is, if you're in a lucky situation, then have Power BI Premium available. So this means at least there could be a gap of 30 minutes between detailed data and aggregation data. But some days, weeks, months, 1, 2, 3 months ago, the Power BI Power Platform team released something in Flow that is the API refresh of Power BI datasets. And now if I'm triggering somehow this API refresh with, I just said Flow, right? But now it's called Power Automate, sorry for that. So whenever I'm saying Flow, I mean actually Power Automate. So this API refresh, it does not count for this 48 times in Power BI Premium. This means if I'm having Power BI Premium, I can trigger this API refresh with Power Automate every minute, every second, or every 5 seconds. This does not count for Pro.
Well, you have to keep in mind that this call of the refresh is actually an asynchronous call. So you can trigger the refresh every 5 seconds, but if your refresh takes 10 minutes,
it's not
really
that reasonable.
But just to mention that.
So, and as we learned, or as I learned, if I'm referring to these, let's say, docs thing, I learned the hard way that they change sometimes. So for this reason, there's a copy in this slide and also a link in the notes that says datasets on a premium capacity don't impose limitations for API refresh. So today. Maybe this will change again the other day or the next week, but maybe not.
Hopefully.
So now, architecture.
Any questions regarding the design so far? Are those topics that we mentioned clear? Does it make sense that you have to think about those topics we just... Yeah, a question?
Is there an alternative for an aggregated table Power BI other than the ETL process?
So let me repeat the question. The question is if there is an alternative to creating an aggregation table in Power BI apart from the ETL process. I'm not 100% sure what you mean with ETL process.
Sorry, populating or loading.
Yes. Okay. So is it necessary to actually populate the data in the aggregation table? That was your question, isn't it? You are allowed to keep the aggregation table also in direct query. This would, of course, solve the issue. If the detail table and the aggregation table are both direct query, then, of course, you can keep the sync on another level. That will be possible. But if you actually want to achieve the highest improvement in speed, then the recommendation definitely is to use the aggregation table in import mode, which means you need to populate the data, and then there is no other possibility. Okay? Other questions? Okay. So actually, this slide is just mentioning what I just repeated. So if we recap what we have to consider as a starting point for the architectural part, when we are talking about the design, we have to keep in mind that the limitation for the detail table is the whole thing only works if the detail table is in direct query mode. It's not working if the detail table is in import mode. That's not possible. You cannot have import and import. That's not supported. And unfortunately, if you're using live connection, you don't have any options at all. If you're using live connections, you're still bound to, and let me recap, live connection is connecting to an analytical engine like SAP BW, Analysis Services Tabular, or Multidimensional. Then you can only connect to one data source. You don't have any other opportunities. For the aggregation table, you can decide if it should be direct query or import, together with the consequences we already mentioned. And if you have shared dimension tables, that means dimension tables that are related to both the detail and the aggregation table, then you have to decide about the storage mode for those tables as well. If both fact tables are in direct query mode, that's easy. The dimension tables should also be in direct query mode. If the aggregation table is in import mode, the high recommendation is to keep the dimension tables in dual mode. As I mentioned, they are behaving in regards to which table they are actually queried with. You have the possibility to leave them in direct query mode, but this might lead to unexpected behavior in some situations. So this is an interesting topic if you want to play around with this, to test this out in DAX Studio, how this behaves in regards to your queries, but it's definitely not recommended. Maybe one final comment about these storage modes. You can shift between direct query and dual as much as you want. You can also shift between direct query and import, but you get never back from import. As soon as you set a table to import, it stays import. There's no way to go back. So if you try,
maybe you consider doing it once again.
Yes.
Doing it once again is maybe way back.
Yeah.
Okay, but it doesn't count, I guess. So it's about, this aggregation thing is about, I create an aggregation table that contains less data than the detail table. This is all about, I guess. This is the summarization of everything. Clicky, clicky, draggy, droppy, and what we already mentioned so far. And then we have to just, if this is clear, aggregation table, less data, detail table, more data, then we just have to consider how to overcome this situation with the gap of both tables are sync. There are a lot of direct query data sources, meaning these data sources can be used for our detail table. And if we are considering, or coming back to this, what I already mentioned, is about the single sign-on aspect, then just some of these direct query data sources remain. This has to be considered for, or when we have to decide where do we want to store our detail table to. And if single sign-on is something that we have to take care of, then it's just this choice. So now?
Another new wording. Actually, just a quick story. Actually, the title of this table of this slide was Azure SQL Data Warehouse until Ignite. Then we renamed it to Azure Synapse Analytics because it seemed like this is more or less the new name of the cool new feature, which is somehow a combination of Azure SQL DW and Azure Data Lake. And we named it formerly known as Azure SQL Data Warehouse, which we today actually found out is not correct. I'm sorry about that. So let's call it Azure Synapse and Azure SQL Data Warehouse, or however Azure SQL Data Warehouse will be called in the future. Yeah? That's more or less the precise situation. So Azure Synapse is not the replacement of Azure SQL Data Warehouse. It is just a very, very cool, promising new technology containing Azure SQL Data Warehouse. So, okay, just to keep this short at the moment. Okay, so actually we were talking about Azure SQL Data Warehouse. This is also what was the direct query data source in my demo. And well, why is Azure SQL DW a good or might look like a very promising data source for Power BI reports? Well, first of all, it's a SQL data source, which to me, coming from a Microsoft SQL Server environment, is looking pretty familiar. It supports this approach of data warehouse modeling that I used all my BI developer and BI consultant time of life because, well, it's a data warehouse. You can easily apply a star schema. It looks nice. I can use T-SQL to query it. Great. Yeah? Makes sense. Even on top, the polybase feature, which actually makes SQL DW that interesting, allows you to have a kind of virtualization approach that even goes beyond just keeping the data in your Azure SQL DW. It allows you to actually create external tables, external table definition inside your DW, which, for example, allows you to query data that is lying in an Azure Data Lake as CSV files, for example, directly by applying T-SQL statements as if this would be just another table inside your DW, and you don't even have to publish to load the data into your DW. You can directly reach, so another type of query folding, you can actually directly write T-SQL queries onto this data still residing in the Azure Data Lake. If this is performant and quick, it's another question, but it works. Yeah. So, but just to mention that.
Today we learned Azure Synapse will also solve the performance.
Let's phrase it differently. Polybase is not the quickest feature to gather data from there, but it's improving a lot, and Microsoft is really heavily investing in making this whole kind of virtual queries and combination of those different technologies fly. And we are really, so I was really thrilled. There are, if you are interested in something like this, there are more sessions about this coming. For example, I know that tomorrow there is a very interesting session. So if you see something about Azure Synapse, go there, or Future of Data Warehouse. Okay, apart from that, as you already mentioned, or as we mentioned, they are really interested in making this whole Azure SQL Data Warehouse approach competitive again. You have, with tools like Snowflake, also a sponsor here, or for example, Athena, you have competitors in the market who are heavily working against Microsoft being one of the market leaders in that area. Azure DW is really strong, but it has its limitations at the moment, but those limitations are known, those limitations are worked at. So, it looks really promising, and in my opinion, it also is. So what could be reasons not to use Azure SQL DW? One reason actually could be costs. It's not really cheap. You have a split between compute costs, so when you're actually running queries on top, and the actual storage. Compute, you can actually pause and resume. You only pay for the time when it's actually running, so this is something which you can work on. But this is also really expensive, especially when you need a lot of performance. Storage is, of course, as the queries should be pretty quick, is premium storage. And, well, they think it's a big data model, so they count in terabytes. You either get 1 terabyte or 2 terabytes or so on. So it's not really, it's not scaling as smoothly as you would hope for. And for storage, you are paying all of the time because data is residing in this storage. So there is things you need to consider when you're talking about that or thinking about that. As we mentioned, there were some very important releases to improve performance and security. So workload management, for example, which as far as I know is still in preview, or is it already GA? I'm not sure actually, allows you to actually define workload groups and to really decide which parts, which queries, which users, for example, are preferred in their workload. So you can run things like your Power BI reports or reports from your CEO the quickest. So you have some kind of influence how this is actually working. It is supporting columnar storage and columnar ordering on top of the data, which is pretty cool stuff. And you can use a lot of those things that you see here. So it's actually, they are really working on improving the possibilities. And things like row-level security haven't been available in the beginning. That has been added. Data masking and threat protection are also important features that should allow you to actually improve the usage of the data and the securing of the data inside. I'm sorry. So if you're using Azure SQL DW for your detail table, there are 2 options, as I already mentioned. The first option is to use this poly-based approach with external tables. That would, for example, allow you to keep your data residing in your original, even in your farther away original data sources, but to provide a data warehouse-like, relational data warehouse-like structure on top with those external tables, and to actually use this just to mask the way how you're accessing the data. But you have to keep in mind that you're using this as a direct query data source from Power BI, which means Power BI DAX query would be translated into T-SQL, running against Azure SQL DW, being translated in whatever you need to get the data from the original storage, which, of course, takes some time. Yeah? There was a question?
So say we have a capacity.
Yes?
And we want to do aggregated tables.
Yes?
Direct query. Can the direct query be connected to an on-prem source with a gateway or something?
Yes.
Very good question. Question was, you have a premium capacity, you want to use aggregation tables in direct query mode. Is it possible to use an on-premise data source for that direct query mode by using Gateway? And you actually mentioned the word yes. Gateway is supporting direct query mode for, I'm not sure, I don't think for all, but for a lot of direct query data sources.
Yes.
I'm not 100% sure, but that's possible, yes.
But for this scenario, if you're using direct query, then you necessarily do not need premium. Because
Aggregation is not a premium feature, it's a pro feature.
Aggregation is not a premium feature. Pardon?
So,
It was a premium feature until recently?
So there is always some kind of irritation, or confusion, that's the word I was looking for. What actually is Power BI service features and what is Power BI premium features, and I'm sometimes mixing that up, but I'm sure that composite models and aggregation tables are standard service features. They were in the preview. I think in the preview in the beginning they were in premium only, but that might be the case. You have things like incremental refresh, for example, that are premium only features. That's correct, but aggregation tables and composite model actually are available for all Power BI users. But still, premium, of course, allows you some other capabilities and some storage which might be helpful there.
just one thing to add, if you are using on-premises data sources, you have to consider that you are scaling your gateway properly, because data is rushing through the gateways, and maybe if you have 2 data sources, then you also should use 2 gateways accessing the aggregation data in the detail table. Yeah.
Okay. Coming back, so first of all, you can use the polybase approach, which is more or less direct query on direct query, if you want to name it like this. Or you can actually store the data in your Azure SQL DW, which will improve the performance in most of the cases significantly, because then you're doing a direct query against your Azure SQL DW. There is still a topic we need to consider, which is, and now I lost the word, how many queries are run in parallel?
Concurrency.
Concurrency, I'm sorry, I lost the word. Because Azure SQL DW, depending on which scale you're actually running at, is limited on not how many connections are built up, but how many queries are actually run in parallel, which is especially important when you're thinking about a Power BI dashboard. So if you think about, or a Power BI report, if you think a Power BI report with 10 pages, 8 visuals on each page, you have 80 queries run against the Azure SQL DW.
No, just 1 page.
Or just 1 page. It doesn't depend on the pages, but you have several queries run in parallel. If several users with several security caches are running those queries in parallel, then you can get a lot of queries sent to the data source in parallel, which can lead to concurrency issues. This will not raise any failures or something like this, but it just takes some time. There are also improvements for this, like query result caching and so on, but this is definitely something you need to keep in mind. This is actually not depending on if you use polybase or if you persist the data in the data DW, but just a feature of the DW. If you persist the data, of course, you will need storage inside the DW where you persist the data, so you have to pay for the storage. And of course, you have to keep track of this ETL process, however you are doing this, that persists the data coming from the original data sources, like a data lake, into the Azure SQL DW. So another synchronization step that you need to plan for and that you need to keep track of. Okay, so we just tried to actually rewrap this in, let's say, a kind of metrics that will help you maybe with decision making. We mentioned all of this before. This is just for you in the handout to actually allow you to hopefully recap this a little bit. But yeah, I think this should be helpful. There is a question?
You say there might be a third option to what you, the previous slide. You can use polybase to load data into physical tables inside of your data warehouse. Were you using both texts?
So I got that you want to know if there is a third option by using polybase, but I didn't get the rest.
So what you would do is you could use polybase to connect to an external table.
Yes.
And store that onto a table that you actually materialize in the database.
Yes. Okay.
Polybase is your ETL.
Yes. Okay. Maybe I just didn't explain this properly. So the question is if it would make sense to use polybase as the technology for your ETL process. So you are creating your external tables and you are just using T-SQL to say, please insert or update or whatever from my external table into my persisted table or materialized table or materialized view, which is another option inside my Azure SQL DW. That is, of course, possible. So how you design this ETL process, if you use Databricks, for example, to push data in, or if you use polybase to create this, this is your decision. But polybase is a good option. This is actually what polybase is meant for most of the times in Azure SQL DW. That's okay, or that's absolutely true. But still, in this case, you persist the data in the DW, so you need the storage. So it's just a different way of how to design the ETL process, but the consequences are the same. Okay, thanks so much. Good contribution. Okay, so just to capture this, we try to set up those different situations here. So you can either use a view in the Azure SQL DW and keep the data in the original data sources. You can use a materialized view, which is actually handling this kind of persisting the data itself. So the engine is actually detecting when new data is available in the data source and is just refreshing this materialized view. So this could be an option to avoid the situation of handling this kind of update process. Persisting the data by an ETL process that you're choosing yourself is another option. And the third option is just to actually import the data into your Power BI data set. Of course, this combination is applicable for the aggregation table, because if we remember, the detail table is not allowed to be in import mode. But if you decide to have the aggregation table in Azure SQL DW as well, those would be the 4 different options how to actually handle or how to actually implement the aggregation table inside your Azure SQL DW. Okay? So we try to actually create different use cases that could be applied for the main 2 setups of the aggregation table. So is the aggregation table in direct query or is the aggregation table actually in import? And I think I mentioned a lot of Azure SQL DW so far, so I will just give over to your approach.
So actually, maybe there was already a question about the ETL processing and Polybase using things like that to process data, but it's not necessarily just that, because we also are confronted with streaming data that rushes into our realm, and we have to somehow conquer this. And now we are having this gap between detail table and aggregation table. This is basically what makes me mad, and I'm always trying to reduce this gap. And now we are architecting solutions where we are streaming data in parallel the detail table in a larger store and aggregating it with, for example, streaming analytics. That we do not have any longer this gap, but this means we have also direct query for both of the kind of tables, meaning direct query for the detail table and also as the aggregation table. In some of my projects, the gap between the available data in the aggregation table is much more important than the performance. And if you are scaling up the underlying technologies, then we are also get very well performance with direct query sources, but maybe it's a little bit costly.
And of course, you can also apply this kind of approach to no, I'm sorry, I got a little bit lost here.
So actually, direct query is also, here the first option is why we have to use direct query also for the aggregation table. Sometimes it's necessary that, or can be possible that it's not allowed to store data in this, let's say, cloud thing. So it's still sometimes not possible to store data in Azure SQL or the Power BI service. This means also the aggregation table has to be direct query. Yeah. This means on-premise, and so maybe it's just some kind of compliance or governance thing.
That's actually also referring to your question, if direct query to on-premises data sources can be implemented, and that is the case.
Yes.
And with us coming from Germany, cloud is still something which most of the customers are afraid of. So
no, not most.
Okay,
Some.
less and less. Fortunately, less and less. But we still have the situation that data is not allowed to be pushed into the cloud, so that's the case. With this, we're at the end. Thanks for your attention. Thanks for being here. Enjoy the rest of the day. We'll be here for questions also the next 2 days, and enjoy the rest of the conference.
Thank you.